Okay, so we're given two bananas, one with a mass of 90 grams and the other with a mass of 400 grams. And we need to find our acceleration and our tension. So then
You ready to go? Get your eyes down.
we know that F is equal to ma, which is always the case. It's on our equation sheet. So when we have that, right, well, okay, in our case it's going to be Fg. So the force of gravity is equal to mass times acceleration. And since we have multiple masses, we're going to have to write out, instead of just force of gravity equals mass times acceleration, it's going to be Fg1 plus Fg2 is equal to the mass 1 plus mass 2 multiplied by A. So you can see this from here. And now that we have our values here, obviously we need to convert these to kilograms. So mass 1 will be 0.4 kilograms, and then mass 2 will be 0.09 kilograms. And when you multiply this by 9.8 on each of them, you get your forces of gravity, which should get you 3.92. And then you minus 0.882. So you might be asking why the minus. It is because this force is being pulled up as this weight is a lot heavier than this one. And then make that equal to the original masses added together. And now we should have our A left. So then our original masses are 0.4 kilograms plus 0.09 kilograms and then A. So now we have our actual equation to find acceleration, and now we just need to move things around and move things to the other side. So then 3.92 minus 0.882 should be 3.038, which is equal to 0.49 A. And then once we divide 3.038 by 0.49, we get A is equal to 6.2 meters per second. So you're going to have to always remember about this equation and this equation for problems where you need to solve for acceleration and tension, which you will see in question 3 as well. So then what is our tension? So now that we got A is equal to 6.2 meters per second, it can actually be pretty easy because according to Newton's second law, tension minus mass times gravity, in this case we'll actually use M2 because tension is on the same for both sides. So tension minus M2G, and then make that equal to M2A. So that is what Newton's second law states, but we are just trying to find tension. So we can actually move this to the other side where it will become T is equal to M2A plus M2G. And now that we did this earlier, we actually have all of our values. So using the mass number 2, 0.09, we can simply just plug in. So then this becomes T equals 0.09 times 6.2 plus 0.09 times 9.8. 9.81 if you want to be extra specific. And when you multiply all these together, it should add up to 1.44 newtons. And that's our answer.
Wow.
Okay, so we're given two blocks. One of them is on a surface and one of them is suspended. And you can see our masses over there are our block 1, which is M1, is 2 kilograms. Our mass 2, which is block 2, is 1.5 kilograms. And our coefficient of friction, which is acting on block 1, is 0.400. So before we even begin this process, we should label our free body diagram. So we have our force of gravity, 1, for our block number 1. And then we have our tension force, which goes this way. We'll label that as Ft. And then we have force of gravity 2, Ft up here. And then on this side, since we have a coefficient of friction, there's a force of friction. So there's F, I will say Fk for friction. I could just say F. Anyways, so based on that, so we need to find our acceleration and our tension based on that. And based on what we learned earlier, saying that Fg is equal to ma, we can do that same exact thing, except our block 1 now has a force of friction acting on it. So instead of just writing the force of gravity of 1, we need to add our coefficient to it. So it will become Fg1, and you would multiply our Fg1, the force of gravity of the first block, by our coefficient, so mu k. And then you would add our force of gravity 2, and then make that equal to m1 plus m2a. So now that we have that, we can actually just start plugging in so that we can find our acceleration. And when we plug in our force of gravity, we should have, well, obviously when you multiply by 9.8, you should have 19.6 times 0.4. So then that's one entirely different thing here. So I'm gonna put it in brackets. Oh, okay. One thing I forgot is that since friction is pulling backwards, it is negative. So negative. And then plus the force of gravity of the second block, that should be 14.7 is equal to, so then mass 1 plus mass 2, that's 2 plus 1.5, so then that should be 3.5a. So now we can add together. And when we add all of this together on this side, we should get 6.86 is equal to 3.5a. And then we divide each side by 3.5, and we should get a is equal to 1.96 meters per second. So when it comes to finding tension, we have a very similar thing here. So earlier we did T is equal to m2g plus m2a. In our case, right, so we are using the second block here, and our acceleration, our acceleration is actually negative here. So this would change to T is equal to 2g minus m2a. And then once we have that, we can start plugging in. So then T is equal to 14.7 minus 2.94. And now our T should become equal to 11.76 or 11.7 newtons. And that's our answer.